Alright, in this video we're going to talk about section 6.2 day 2, and then we're going to still talk about parabolas. So in the last video we talked about the standard form of a parabola being what you see on the screen now, x minus h squared equals 4p times y minus k, or y minus k squared equals 4p times x minus h, where p is going to be the distance from the vertex to the focus. Now we saw in class the other day an example similar to what we're going to look at here, but we're going to use these ideas to come up with the equation of a parabola given certain features of the parabola. So if we look at example 1, find the standard form of the parabola shown below. So the first thing we want to look at is we're opening to the left. So that tells us a couple things. That tells us that our form is going to be y minus k squared equals 4p x minus h. It also tells us, not that it's super important, but since we're opening to the left, we know that when we find p, it's going to end up being less than 0. Now, looking at the picture, we can see clearly that the vertex is going to be 5, 3. So that means hk is going to be 5, 3. So if we plug 5, 3 into our problem, we're going to get y minus 3 squared equals 4p x minus 5. Now we need to figure out what p is so we can figure out our equation, right? We're still missing the p. So we're going to handle this the same way we did in class the other days. We're going to take the point 4.54 and plug it in for x and y and try to solve for p. So when we do that, we're going to get 4 minus 3 squared equals 4p, 4.5 minus 5. So 4 minus 3 is 1 squared is 1. 4.5 minus 5 is going to be negative 0.5. So we can think about 4p times negative 1/2. Now we could multiply 4 times negative 1/2 and get negative 2, divide by 4 and figure out what p is. But if we think about what we're doing, we can save ourselves a couple of steps. We know we need the value of 4p in the problem. So if we think about 4p here as its own little variable and solve for 4p, we can just kind of go from there and plug that value in. So if we multiply this by negative 2, we're going to get that 4p equals negative 2. And we can plug that straight back into here. We don't really need to solve for p. We could divide by 4, but then when we plug this back in, we're going to be multiplying by 4 anyway. So if we solve for 4p, we can plug that straight back into our problem. And we're going to get y minus 3 squared equals negative 2 x minus 5. So that's kind of a review of what we did in the last video, in the last lesson. So the new stuff for this lesson is going to be tangent lines. So the reflective property of parabolas says that the line that's tangent to a parabola at point P makes equal angles with the following two lines. One, the line passing through P and the focus, and the line that connects, and the axis of the parabola. So there's a little diagram showing what we're looking at. So we have our tangent line right here. So remember, a tangent line is a line that's going to intersect at just one point. So this line is drawn in such a way that it's going to only intersect this parabola right there at point P. And the parabola is going to kind of curve off, and this is going to keep going straight. So this angle that's made between the tangent line and the line connecting the focus to P has this angle they call alpha. And the tangent line and the axis of the parabola also make an angle called alpha. So what we're going to try to do here is find the equation of the line tangent to y equals x at the point 1, 1. Now this is going to be a very common question next year in calculus, although we're going to solve it in a different way next year. We're going to use derivatives. But we don't have derivatives in our toolbox yet, so we have to use the idea that we're going to have those congruent angles. So to start, let's just take a look at the picture of this graph. So we know that it's going to open up. It's x squared. We have a positive p, and our vertex is 0, 0. So it's just our plain old parent function. Oops. Change the color. Plain old parent function y equals x squared. So we're going to have the point 1, 1. And we're going to draw the tangent line to that point 1, 1. So our tangent line is going to look something like that. And the question wants us to come up with the equation of that tangent line. So ultimately our answer is going to look like y equals mx plus b. So we can think about this point down here, our y-intercept. We can call that 0b, and that'll be our intercept over here. So we need to take advantage of the congruent angles that are going to happen when we draw in these lines that connect the focus to P, so this line here, and the axis of our parabola. So in that diagram we saw before, we saw that this angle and this angle here were congruent. Now, if you remember your geometry, if those angles there are congruent, this side here and this side here are going to be congruent. So we can call this side right here, that length, let's call it D1 for distance 1. And we know, let's call this one D2. So we know that distance 1 has to equal distance 2 because they're going to be the two legs of an isosceles triangle. So if we can find distance 1, we can find distance 2, we can find b, we can come up with the slope of a line, we can come up with the equation of a line. So all of this is going to be dependent on what our focus is. We have to find the focus of our parabola. So if we're looking at y equals x squared, we know that out front here is our 4p. So 4p equals that 1 right there. So we know p equals 1/4. So that tells us the focus is 1/4 away from the vertex. So we know the focus is going to be at the point 0, 1/4. So we can kind of stick that in there, 0, 1/4. So if we think about D1, D1 is going to be the distance from our focus down here to B. So we know D1 is going to equal, well, 1/4 gets us to 0, and then B gets us past that. So D1 is going to be 1/4 minus B. And this is going to end up working because when we find B, B is going to end up being negative, right? We can see it's below here. So when we find minus a negative number, we're going to be adding B to 1/4, so that's what's giving us that value there. So D1 is going to be equal to 1/4 minus B. And we could find D2, we could find a numeric value of D2 just by using our distance formula, right? It's just the distance from 0, 1/4 to 1, 1. So we can find the distance there by doing the difference of the x values, 1 minus 0 squared, plus the difference of the y values, 1 minus 1/4 squared. Take our square root. And if you work that out, get common denominators, we're going to end up at 5/4. So we know that D1 is 1/4 minus B, D2 is 5/4. So since we know D1 has to equal D2, we know 1/4 minus B has to equal 5/4. Well, move B to this side, move 5/4 to this side, we're going to get B equals -1. So we know part of our equation. We know B is equal to -1. Now we just need to find the slope. Well, if we now know that this is the point 0, -1, we can find the slope between this point and that point because they're both on the tangent line. So we know the slope is going to be equal to 1 minus -1 over 1 minus 0. So our slope is going to be 2. So if our slope is 2 and our intercept is -1, we know we have y equals 2x minus 1 as the equation of the tangent line. So that's going to do it for this video. We'll see you in the next one.